All right, if we know the roots of a polynomial, we can work backwards to find the equation of the polynomial. If x equals 2 is a root, what is the factor? The factor would be x minus 2. If x equals negative 1/3 is a root, what is the factor? The factor would be x plus 1/3, which we typically don't write it as a fraction. We can take this denominator, slide that denominator back in front of the x. So the factor would be 3x plus 1 would be the one we want to use. All right, our example, we want to write the equation of the polynomial with the given roots. Negative 2 is a root, so x plus 2 is a factor. 1/2 is a root, so x minus 1/2, we bring the 2 in front. So 2x minus 1, and then 1 is a root, so x minus 1. We would then just multiply all these together. We can use a box. We're going to have to multiply twice. X plus 2 and 2x minus 1, that gives me 2x squared. X times negative 1 is negative x. 2 times 2x is 4x, and 2 times negative 1 is negative 2. We combine like terms. So we get 2x squared plus 3x minus 2 times x minus 1. And then we can draw a box for that. X minus 1, 2x squared, 3x, and negative 2. That's 2x to the third, 3x squared, negative 2x, negative 2x squared, negative 3x, and positive 2. We combine like terms. We get 2x to the third, 3x squared, and negative 2x squared is 1x squared, negative 2x and negative 3x is negative 5x, and 2. So we have worked backwards. All right, number 2 talks about a multiplicity, 3 with a multiplicity of 2. All that means is that we have x equals 3 twice. So we're going to have the factor x minus 3 2 times, and then negative 3 over 2 would be x plus 3 over 2, which is 2x plus 3. We multiply x minus 3 times x minus 3. We can FOIL or draw a box. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times 3 is 9. We combine like terms. We get x squared minus 6x plus 9. And we're going to multiply that by 2x plus 3. We can also draw a box for that. 2x plus 3, x squared minus 6x plus 9. 2x times x squared is 2x to the third. 2x times negative 6 is negative 12x squared. 2x times 9 is 18x. 3 times x squared is 3x squared. 3 times negative 6 is negative 18x, and 3 times 9 is 27. Combine like terms, we get 2x to the third. Negative 12x squared and 3x squared is negative 9x squared. 18x and negative 18x look like those cancel, and then we're left with a 27 at the end. And that would be our polynomial equation that has roots 3 with a multiplicity of 2 and negative 3 over 2. All right, the conjugate root theorem. Remember that roots can be rational, irrational, or imaginary. If we have irrational or imaginary solutions, we can use the conjugate root theorem to help us find additional zeros. Irrational roots will always come in pairs of conjugates. What do we mean by conjugate? The conjugate of a plus square root of b is a minus square root of b. So if 6 plus square root of 3 is a solution, then so is 6 minus the square root of 3. If negative square root of 5 is a solution, then so is positive square root of 5. The same is true for complex or imaginary roots. They will always come in pairs also. This means that if 5 minus 7i is a solution, then so is 5 plus 7i. If 3i is a solution or a root, this means that negative 3i is also a root. This only works for irrational or complex roots. A polynomial p of x with rational coefficients has the given roots. Find all additional roots. 2 over 5 is a rational number, so there is no additional roots for that. 3 plus square root of 7 is an irrational root, so 3 minus square root of 7 would also be a root. If negative 4i is a root, that's imaginary. Positive 4i would also be a root. The least degree would be the number of roots that we have. So we have 1, 2, 3, and 2 additional roots. So we would have 5 total. So the least degree would be 5. Negative 5 is a rational number. It does not have any additional roots. 3 is a rational number. It does not have any additional roots. 4 plus 7i is an imaginary number, so 4 minus 7i would be the additional roots. The square root of negative square root of 17 is irrational, so it would have an additional root, the positive square root of 17. We would count the number of roots that we have. We had 1, 2, 3, 4 given to us. We knew that there are 2 additional roots, so it would be 6 roots total, so the least degree of this polynomial could be 6. All right, example, we want to write the polynomial with rational coefficients that has the given roots. If we want to write a polynomial, we're going to write out the factors. So if a is a root, then x minus a is a factor. And then we're going to multiply carefully. So if negative square root of 7 is a root, I know that positive square root of 7 is also a root. And we can write out these factors. Negative square root of 7, the factor will be x plus square root of 7. Positive square root of 7, the factor would be minus the square root of 7. And the factor for 3 would be x minus 3. We would multiply these together. We can draw a box to multiply those if we choose. X times the square root of 7 and x times the square root of 7. X times x is x squared. That one should be negative. X times negative square root of 7 would be negative square root of 7x. Square root of 7 times x would be positive square root of 7 times x. And square root of 7 times negative square root of 7 would just be negative 7. The negative square root of 7x and the square root of 7x cancel, so we're left with x squared minus 7 times x minus 3. We can draw a box for that also. X squared minus 7, x minus 3. X squared times x is x to the third. X squared times negative 3 is negative 3x squared. Negative 7 times x is negative 7x, and negative 7 times negative 3 is 21. We combine like terms if we have any. Our polynomial least degree would be x to the third minus 3x squared minus 7x plus 21. Let's look at a polynomial that has imaginary roots. Let's look at a polynomial that has imaginary roots, in this case 5i. Negative 5i would also be a root. So my factors would be x minus 5i times x plus 5i. And to do the fraction, we're gonna it would be x plus 1/2, but we don't want the fraction, so we bring the 2 in front of the variable, and we get 2x plus 1. We can draw a box here to multiply the first two together, the x minus 5i and the x plus 5i. X times x is x squared. X times 5i is 5xi. Negative 5i times x is negative 5xi. And negative 5i times 5i is negative 25i squared. I squared equals negative 1. So negative 25 times negative 1, which is I squared, is going to turn the negative 25 into a positive 25. The 5xi and the negative 5xi cancel. So we get x squared plus 25 times 2x plus 1. We can draw an additional box to help us multiply that. X squared plus 25, 2x plus 1. 2x times x squared is 2x to the third. X squared times 1 is x squared. 2x times 25 is 50x, and 25 times 1 is 25. So our polynomial of least degree would be 2x to the third plus x squared plus 50x plus 25. That would have the given roots of 5i and negative 1/2.